Yes, hi, this is George Larax again, and today I want to do a problem from a student of mine from a Hunter College High School, and the problem is on related rates. I find this problem a little bit challenging, so that's why I would like to share it with you. So what is the problem? The problem is that we have that a runner is running around this circle here, that we know the radius, and there is another person sitting in a distance in D from the center of the circle, and we know that the runner is moving with the velocity of 7 meters per second. We know that the distance OD is 200, and we know that the radius is 100 meters. So we want to find how fast is the rate of change of distance between the A and D, like between the runner and this here stationary observer. So we want to find how fast is this distance changing when the distance between them will be 200 meters. So in all these problems, the main thing is to find the right formula that will give you the answer. So by right formula, we mean the formula that contains the what is given and what you are looking to find, which it will produce the right result, which is what you are trying to find. So here actually this formula is not other than the cosine law. So here what we have with lower O, it's this distance here. A we said is the this distance from here to here, which is 200, and R is the radius. So if you take the cosine law in this triangle here, AOP, and O is this here, we have that O square is equal with A square plus R square minus 2 times AR times cos of omega t. Omega t is this angle here, so since the runner is running with constant speed, so that means that also the angular velocity omega is constant, and this is the angle that it will cover in time t. So now if we take the first derivative in both sides with respect to t, we will have that 2o do over dt. These two they are constant, so the derivative is 0. So we have minus 2ar times, now the derivative of cos is sine, so it will be sine omega t, and because you have to use the chain rule, it is also times what you have inside, so times the derivative of what you have inside, which is omega t. So the derivative of this is omega, so we put the omega here, and of course the derivative of cos is minus sine, so minus with minus they cancel, so we have this answer here. So that's the first equation, and here we can cancel the 2's. Okay, so but still we cannot get what we want because we don't know how much is t. But now we take a second formula, which is actually now the sine rule. So we take it again in this triangle here. Okay, so now before I continue, this triangle here, it's an isosceles triangle. Why it's an isosceles? Because both the AP and the PO, they are equal. We want to find when both of, when AP is 200. So now we apply the sine law in this triangle here. So we have the sine of omega t, so the sine of omega t over O, which is the side across, is equal with the sine of pi minus 2 omega t. I mean, over r, which is this here. So this is the angle, and this is the side. I mean, this angle here, it's pi minus 2 omega t, because if this is omega t, this is omega t. So the sum of the angles of triangle, it's p, it's pi. So that means that this angle here, it will be pi minus 2 omega t. Yeah, let's continue from here. So now this here, it will be equal. Now I use the trigonometric identity, where the trigonometric identity is sine of a minus b, where a is the pi and b is the 2 omega t. So this will give you sine of pi times the cos of omega t, of 2 omega t, sorry, minus cos of pi times the sine of 2 omega t. Now the sine of pi, it's 0, so all this goes away, and now the cos of pi is minus 1, so minus the minus is plus, so this will give you plus sine of 2 omega t. And now I use the trigonometric identity sine of a plus b in order to find how much is this. So I've split this in omega plus omega, omega t plus omega t. So that will be equal with sine omega t times the cos of omega t plus cos omega t times the sine omega t. So these two are equal, so it's 2 times this over r, okay? Because this, we said it was equal, we started this, okay, and we're working on the numerator, and of course we have to add the denominator, and we know that all of this is equal with the sine omega t over O, okay? So now the sine with the sine cancel, and if we solve for cos omega t, it will be equal with r over 2O, so that will be equal with 100 over 400, so that will be equal with 1/4. So we know that the cos of omega t is 1/4. So, we use now the trigonometric identity sine square plus cos square is equal with 1. So that means that the cos square of omega t is 1/4 square plus the sine omega t squared. That should be equal with 1. And if you solve this for sine omega t, it will be equal with plus or minus the square root of 15 over 5. And now you go to this here, and we have that d over dt is equal with ar omega. Omega is v over r sine omega t. And we bring also the o here. So the r with the r cancel, and the a with the o cancel, okay? A is this and o is this, they're actually the same. And if you put everything, so the only thing which is left is v, the velocity. So the answer, it will be plus or minus 7 square root of 15 over 4. And of course we have, this is when the positive value, this is with the positive value, and of course you have another one which is right here, which is with a negative value. So thank you for taking the time to view this video, and I hope you find it useful, and bye for now.